Mr. Abdulwasi, Abdulhafiz, you can unmute yourself and start presenting. Since Abdulhafiz Abdulwasi is not here as well, maybe we can move to the next presenter. Mr. Joseph Akpan should be the next presenter. Maybe you can
Yes.
start now.
Oh, thank you. Thank you so much. Please, can you confirm if you can hear me?
Yes, we can hear
Yes,
you
we can.
clearly.
And we can see your screen also.
Oh, great. Thank you so much for the opportunity to learn from this forum and for also the opportunity to share the thoughts together with my team we have been working on, which is on um, green democracy, about integrating generative AI, blockchain, renewable energy management towards sustainable electioneering. Okay, I would just put on my video. Okay, great. Okay. So here's the outline of my presentation. I would do a definition of some terms and some bit of literatures and conceptualization behind this research, some bit of mathematical formulation findings, and yeah, conclude and provide some direction which can assist in future research. Okay, so what's green democracy? From the name itself, green, it's basically about it's a theory that promotes, puts together the fact that anything behind elections should consider environmental sustainability in place. So obviously, when we talk about democracy, it's basically government that try to make elections free, fair, so which has to do with transparency in terms of the vote casting process and tallying. When we talk about green democracy, it brings in the concept of just a moment, please. Okay, so it brings in the concept of employing low carbon infrastructure to enable this voting to be successful at the polling and data at the polling centers. And obviously, the low infrastructure that low carbon infrastructure based on the data centers that are used to run the polling unit. It also look at avoiding as much as possible sort of manipulations and failures that could actually influence the successful voting and then ultimately success of the elections from being free. And it also enforces that people who are voting are able to trust the system and promote open governance and green accountability. So the part of the generative AI, where does it come in? Basically, we know it as about neural networks that are basically trained on massive data sets and text. For example, the large language model, which is more of a text incorporated um, run AI. So possible uses of it when it comes to elections would be in terms of personalizing outreach by for voters to be able to give them well-informed information, guiding against disinformation. and also to have a kind of interactive support system where voters are able to, or before voting, are able to understand the expectations and also understand where each of the candidates who are vying for any position they stand, and to be able to see if their values is in line with all of that. So it has such possible uses, but the risk is, of course, where people are able to um, influence the system. And by the time the system is being influenced, it could actually affect the elections. And of course, when it also comes to the algorithm behind what could be used in the interactive forum, it could actually send some sort of bias that could affect voters' response to it. So in terms of the algorithm bias, that's where the blockchain comes in, where summarily you could say it's basically identifying a system where you can actually automate and validate um, the voting done by voters, and it can actually be checked run later in future to be sure that the right persons voted for the right persons and there were no influences in the electioning process. So obviously, when it comes to the whole of these green democracies to achieve, like I had mentioned earlier, environmental fairness, environmental sustainability and fairness. So in this presentation, I worked on together with our colleagues some certain metrics that I could use to evaluate based on some perspective analysis we did. The global warming profiles and the life cycle assessment. On that, there are basically 18 categories, but the way we considered 4 categories: the global warming potential, human toxicity, acidification, and electrification. So in terms of the algorithm fairness, so you could see that the DP theta, basically the G, which is on the red, and the G, which is on the pole, it's more like a two group of persons who, for example, you could say we have party A, party B, maybe in the Nigerian context, the PDP, APC. So having a system in place whereby the same set of information where voters who are in this particular party get at the same information where the other party gets, and probably for locations where you could see these parties that are more and the other locations which party are less. So information is being done in such a way that there are fairness in terms of sharing of information, even the infrastructure in place that is used to run the elections. In terms of the renewable energy management concept, is basically when this renewable energy or you look at election polling units that are run by renewable energy system. Now, it might look like it's something not feasible at the moment, but you could see the graph there where you see different countries that in terms of their renewable energy mix in their national electricity mix, about 70% and above. And many countries are doing.
You have 4 minutes left.
Can you hear me?
4 minutes. You have 4 minutes.
Can you hear me?
We can hear you.
Yes,
you have 4
I
minutes
know.
left.
Thank you so much.
You're welcome.
Yeah, thank you so much. I know. Yeah. So where elections are being it's already obvious that the future elections or the immediate future elections would basically maybe run on grids that are renewable energy driven. So that takes us to what would now happen if most elections the elections which are run with national grids that are renewable energy is going to have a lot of effect in terms of maybe peak loading and what could be the life cycle environmental effects when it comes to emissions and effects on other impact categories. So in terms of this mathematical formation, two categories we did, which is if elections is run the first time and if elections is run the second time. In terms of the first time, we look at what will be the total energy requirements and what's the global warming potential and what's the peak requirements. If it's run, maybe a rerun, we look at possibilities that not all polling units will definitely be rerun. So we just assume maybe 20% of the polling units may have to have rerun elections, which it's this R that is integrated into these formulas. So these are the which is just a repetition of the first set of elections. However, but with the rerun factor, which comes into place. So the assumptions we had also made it in terms of the polling units. We assume, let's say we have 10,000 polling units, maybe in a particular country, with 1.5 megawatt that is being consumed the elections, and these are this in terms of the IT lighting and HVAC systems, what would be used. So in terms of the first run elections, this you could see that in terms of the global warming potentials, and there is a 30% reduction across each of the categories. When there is also a rerun, this factor comes in, which is the 20% if impact that has across all of those categories. So we also look at that if all of these things is going to happen, the grid peak load would, by our mathematical computation, would actually be 0.9 of the P baseline, which means that even in with demand responsiveness, there will still be peak of 90% and above, which results in about in terms of the health category of the impact, 20% higher impact, except the grid is run with microgrids. In terms of the mitigation, governance, and future direction for this research, we consider a system where elections are being positioned in high risk zones where you could have a microgrid, and you also have a sort of stronger demand response system to be able to do proper scheduling in case of rerun. And in terms of the governance, look at a blockchain system that is able to put all the fairness possibly to avoid rerun so that there would be no increase in energy demand and emissions. Future research could also look at tying in consensus to real-time electricity, renewable energy availability, and predicting how the grid could run if there is more rerun elections. And this is a technical impact of this with the voters. Thank you so much.
Thank you very much for the detailed presentation.
Yeah.
Thanks. I don't know if there's any question and answer. Maybe we can take that first.
Okay, thank you.
If there is none, maybe we can move
I
to
don't know
the
if I can
next.
stop share. Okay.
Okay. I think
can
there is
stop
none.
sharing my screen. Thank you.
So I would like to invite the next presenter, Mr. Waliu A. Abdul Rashid. You have the floor. You can start now.
Okay, thank you. I'm coming. I want to share my slide. Can you see my screen?
Yes, we can. We can hear you clearly.
Yes. Okay. Good day. I'm very grateful for being here to present my research on absorption of methylene blue from simulated wastewater using the Tony Adafas foliar xylem. By considering the kinetics and the agitation study, and my name is Abdul Rashid Waliu. These are the outlines. Okay, I'm calm. I don't know why this is showing here. Okay, these are the outlines, the introduction, the statement of problem, the aim and objectives, scope of study, and the like. Okay, now to the introduction. The reason why in this study I absorbed methylene blue was because methylene blue is carcinogenic according to several researchers, and most of the time, those that are making use of it, maybe for clothing, to change the color of clothes, and maybe for plastic and others like that, they don't. The water are not being treated before they discharge it into the into the body of the water. And this leads to, I mean, this thing is causing a problem, has caused several problems in which the fish living inside the water have been affected. And in as much the fish have been affected, we, the consumer, we also eat the fish, then the problem is coming back to us. And since we see that the problem is coming back to us, there is need for us to remove, to absorb, if not all, but to remove some percentage of the dye from the water. Now, the effect of methylene blue, I've said, I mean, which is carcinogenic. I mean, there are some other certain effect of it which have been affected, which is affecting we human being. Removal of the methylene blue, I would be using adsorption, because adsorption is one of the methods of water treatment which is very effective. Is not that much. It's not there is. I mean, it's just a simple process whereby the adsorbent in this process, the adsorbent that will be that I used was Tithonia diversifolia, the cellulose from Tithonia diversifolia xylem, and that's used as an adsorbent. And the adsorbent in this case is the methylene blue. This is the sample of the cellulose. Now, as I said, the statement of the problem. Textile water bodies includes a wide range of dyes and chemical additives that make this industry pollutant source. And all these pollutant sources, which are affecting our water, I mean the fish inside the water, other living organisms that are living inside the water, which have been affected. And being affected directly, we have been affected as well. And also, the majority of the ratio of the BOD, biological oxygen demand, and chemical oxygen demand are found about 1.4% number of degradable substances existing. Therefore, all these things we need to work. We need to look for a way to make sure we treat our water, and we make sure we treat our water so as to be able to be useful for us. Methylene blue is one of the major pollutants released from the textile industry, and this, therefore, we need to make sure we provide the solution. That was the main reason we worked on this project in making use of the cellulose obtained from Tithonia diversifolia xylem. The reason being that the reason why we made use of this was because in Nigeria here, the Tithonia diversifolia xylem is just a waste. Most of the places here we see it, and just a waste. And since it's a waste, as a chemical engineer, we need to look for a way to make sure we transform a waste into weight. Because using this something as a waste in our region, and nobody is using it as an herb, nobody is using it for something reasonable. Therefore, that's the reason why we make use of it. We made use of it as an adsorbent, so as for us to be able to use it to treat wastewater. Okay. The aim of this study is to study the agitation and kinetics of methylene blue adsorption using cellulose developed from Tithonia diversifolia xylem, TDS, as an adsorbent. And the objectives of this research work are the first one, development of effective cellulose from Tithonia diversifolia xylem, and the second one is the agitation and kinetic studies. The next one, the scope of this study is just limited to two parameters, which are the effect of time and the effect of agitation, to investigate the removal efficiency and the removal efficiency and absorption capacity of the cellulose obtained from Tithonia diversifolia xylem, which is the same thing as TDS. And also, this is restricted to the absorption process for the removal of methylene blue, because as I was said earlier, the dye considered in this study was limited to methylene blue and not other dyes. The adsorbent used was limited to cellulose. The adsorbent used was limited to the cellulose obtained from TDS, not like maybe some other adsorbent. It's just limited to this cellulose obtained from TDS. These are the literature reviews. Based on Akintola Ibrahim et al. In 2016, TDS was not used as an adsorbent to remediate methylene blue. And in this study, I made use of cellulose from TDS, which is a waste. Also, according to Andayani et al. In 2023, methylene blue was removed, but TDS was not used for the cellulose production. Therefore, it means the first researcher who made use of cellulose obtained from Tithonia diversifolia xylem based on my research, I happen to be the first researcher that made use of cellulose obtained from Tithonia diversifolia xylem as an adsorbent to treat wastewater, and the cost is not that high because due to the process and the process, the materials and methods. The first one is just the collection of materials. The picture of the Tithonia diversifolia is shown below, and I believe all of us, let me say, the larger percentage of us should know this from Nigeria. It's just a waste. And the first one is to collect the materials from, where the material is abundant. I collected the material in Lautech when I was in Lautech. Then after that, the material I peel it to obtain the stem, and the stem is shown below here. After I collect the stem, I ground it. After it was grounded. The only
you have about 3 minutes.
Yeah, I can hear you.
About 3 minutes. You have.
Oh, okay.
Thanks.
Okay. Thank you.
Thanks.
Thank you. Now, after the material was, after the material was blended, then the mesh size I need to carry out my study based on several other journals, I need 20 mesh size. That's the reason why I used I use mesh sieve seeker so as to reduce the size. And after that, I wash it and I carried out alkaline treatment. After alkaline treatment, I carry out delignification. The reason why I carried out alkaline treatments was to remove the hemicellulose part and the lignin content and some other impurities from the cellulose. Therefore, the material was dried. After dried, then another process, which is the delignification, because according to several researchers, in cellulose, the lignin content are high, and the lignin content also, we need to remove it. So as for us to have our cellulose. After that, it was sieved. After being sieved, so as to be able to get it in white, in white color, then in pure color like this, then hydrogen peroxide was used to bleach it. And this is an evidence after the adsorption was carried out, an evidence to show that the material was used as an adsorbent to remove the adsorbate. The next one, these are the results below. To study the effect of the agitation and time, when the experiment was done at 150 RPM, 45 minutes, 52.5 minutes, and 60 minutes, these are the results. It shows that is only at 175 RPM, shows that as there is increase in time, there is increase in adsorption capacity. The values here is 0.34, is 0.371, 0.4235. These are the adsorption capacity. It shows that the higher the time, the higher the adsorption capacity at 175 RPM. Also, we can see that as the agitation rate is increasing, which is 150, 175, that we can see from the time here that the adsorption capacity is also increasing from 0.34, 0.37, 0.50, 0.57, 0.65, and the same thing 52.5. Therefore, we can conclude here that the higher the agitation, the higher the adsorption capacity. And this is the standard curve. After we obtain the value using, which was converted to our linear mathematical equation to study the kinetics. Okay, this is the graph of the adsorption capacity versus time. It can be seen here as that initially, when adsorption has not taken place, it's 0.0. It's just at the origin. As the time keeps increasing, the adsorption capacity also keeps increasing, and there is an equilibrium at 140 minutes. According to this graph. Therefore, we can conclude that as the higher the time, the higher the adsorption capacity from this study. The next one, we can see here, as I said earlier, that based on the agitation, the higher the agitation, the higher the adsorption capacity, and based on this study, the volume of what used was 1 liter. Therefore, the adsorption capacity is still the same thing as the removal efficiency based on the mathematical equation. Therefore, here it can be seen that at 250 RPM, the removal efficiency was 65.71. This shows that at the high rate, at the higher agitation, there is an higher increase in the higher removal efficiency. Okay, in conclusion, effective development of an active adsorbent was achieved using TDS, Tithonia diversifolia xylem. An increase in the time of the adsorption leads to an increase in the adsorption capacity. Cellulose obtained from TDS is effective in treating wastewater based on the removal efficiency and adsorption capacity result. Also, the CERO first, second, and third order models gave adsorption capacity and coefficient and correlation coefficient respectively, which are shown here. And from the study, because as I said, I investigated the kinetics and both the kinetics and agitation. The graphs I showed before, that one is for the kinetic study, which is for the effect of time, and the one of the RPM is for the effect of agitation. It can be seen. SQFM model gave the highest adsorption capacity and correlation coefficient of 0.6854 milligram per gram and 0.8442 over the correlation coefficient. The reason why all the results, the remaining are not accepted is because the rate constant for most of them are negative, and in rate law, the negative we don't consider those values. Therefore, that's the reason why in this study, SFMO gave the best result to study the kinetics effect of for the absorption of methylene blue using cellulose derived from Tithonia difficifolia xylem. Recommendation: it is advised to carry out more research on the regeneration of the used adsorbent via desorption, so as to be able to make use of it for another thing. These are the references. Thank you for listening.
Thank you very much, Mr. Abdul-Rashid, for the beautiful presentation. If there's any question and answer, I think there's a question in the chat. He asked that, please, did you functionalize your cellulose adsorbent? Mr. Abdul-Rashid?
Yes. FTI was done. Yes. FTI was done. But the reason why I did not talk on this on that is because of the limit. I mean, I limited myself to the agitation and kinetic study. That's the reason why I did not talk on it. I functionalized it using FTI.
Okay, thank you very much.
And that was done before the absorption and after the absorption.
Okay, thank you very much. And
Yeah, well.
Okay.
Should
If we
I
have no
stop sharing
question,
my screen?
yes, you can stop sharing.
Okay,
I think
thank
the
you.
next presenter should be Mr.
Thank you.
Ibrahim IT.
Hello.
Okay, proceed. You can proceed. Dr. Temitope.
Okay, I was saying that. Okay, yes, please. I love the presentation. That's like my present research area. So I don't know if the speaker is interested in collaboration, and probably we can drop his contact, whether email or phone number, to talk further or discuss further.
Yes, I'll drop it now. I'll drop it.
Okay, thank you
thank
for
you.
that. Yeah, I think the next presenter should be Mr. DME IT, but I think he's not here yet. So we will proceed to the next person, and that should be Mrs. Sopekun Moyosore. You have the floor, Mrs. Moyosore, Miss Moyosore. You can start now.
Good morning and good afternoon. I'll be sharing my screen soon. Give me a moment, please.
You can share your screen.
Sorry, please just give me a few moments. I think something is wrong.
Okay, take your time.
Apologies. Please, can we move to the next person while I try to sort this out?
Okay, I think the next presenter should be Mr. Adebayo Adiremi. Is he here? Mr. Ibrahim Adebayo Adiremi. Okay, then we have Ehigia Amuso Nowogu. I'm sorry if I couldn't pronounce the name. Are you here? Okay, then maybe we can proceed. I think it's your turn, Dr. Temitope Olubanjo Kende.
Yeah. Okay. Please, you need to give me a minute because I didn't expect it this early, so I need to leave where I am at the moment.
Yeah, we are sorry about that. Okay.
No problem. Okay. Yeah. Just a minute. Okay. I'm going to share my screen. I need confirm if you can see my screen.
No, but we can hear you, but we can't see your screen yet. Now we can see.
You can't see my screen yet.
Now we can see. We
All
can see.
right. All right. Good day, everyone. My name is Kenny Temitokwe. On behalf of my team, I shall be presenting on the topic a hybrid model for high volatility stock market forecasting using seasonal trend decomposition and S3 learning machine. All right. The motivation behind this study is all about one of the richest man on the planet, and that's in person of Warren Buffett. So within his phase of 57 years, S&P 500, a major stock index in the US, make a returns of 24,708%. And within the same period, Warren Buffett made a returns of 3,787,464. And you could see how one can make great fortune from the stock market. So if someone can make this kind of, returns in 57 years, that means you can never be poor again in life. So, and you can get these statistics from the attached web link. And as of today, the worth of stock market globally is $124 trillion, which tells you like there is a lot of fortune you can make from stock market. So this work is actually basically on how you can invest in stock market, forecast what the stock market will hold in the future, put in your money and make profits. So in this work, we try to propose a model called STL-ALM. It's an hybrid model that combines the convolution method with deep learning techniques to predict the stock market. So the STL method decomposes the time series into interpretable components. Then the ELM actually work together in tandem to actually predict the future. And we evaluate the prediction and also subject the prediction to trading to know what actually can be our monetary profit from this said model. Okay, AI revolution in finance started with statistical methods, followed by deep learning, and followed by machine learning. And presently, we are in the age of deep learning, especially attention-based and LLMs. So our proposed method follow these three steps. The first step is the compositions. So a stock market has this kind of data that is nonlinear and non-stationary. So as a result, we try to see how we can linearize this data. So in doing that, we decompose the data to see the evidence of the seasonality or the nonlinear part of the stock data. Also, we try to use ALM to actually model each component of this decomposition, which is the seasonal, the trend, and the remainder. And we try to see how we can use an example model to combine this component together to form a single component. So sorry for the noise. Please. I need to change my spot. Like I said, I didn't expect this lecture early. I was thinking I'm going to be the last speaker. So that's why it came impromptu for me. So I need to leave where I am. Okay, I'm back. So this is our architecture for the model we design in order to predict the future of stock using our proposed model STL-ALM. Okay, we collected data of 4 major stock indices in the world: S&P 500 in the United States, FTSE in the UK, HSI in Hong Kong, and DJI in USA. All these major stock indices are these of developed markets or what we call mature markets in the world. So we set up our experimenter using all these parameters. And after we fit our data and see how the decomposition and the pattern looks like. If you look at this first one, this S&P 500, it shows that this data is non-linear. You could see how it's going up, down, up, a little down. We could see the trend, could see the seasonality, and we could observe the remainder of the component. So we did that for other data. As you can see, the HSI, the DJIA, representing each country. Then from there, we fit our model and we actually got some evaluation metrics, which involve RMS, CMA, PMA, and out. So these are metrics of machine learning or deep learning models to see the lower the error, the better the model. So looking at this, you can see that our model which is the STAELM, was actually the lowest in all these sections. So in RMSE, it has the lowest error. MAE, it has the lowest error. R2, it has the lowest error. Likewise, MAPE. So we also fit to see how our predicted values move with the true values. As you can see, the legend here shows that the true values are represented in blue, while the red values, the predicted values are represented in red. So you can see that there's a kind of alignment between our true values and the predicted values, so that it matches it, a kind of close matching, which means our accuracy is very, very high. And also, it's not just about accuracy when it comes to finance, it's about what profit can generate from the accuracy. Don't forget that in finance, you can make an accuracy, but the accuracy may not give you high profitability. Why? A prediction can be to the opposite, to the right or to the left. So if I'm making predictions to the left, like maybe lower, that is like you are losing money. But if I'm making predictions to the right, that means you are making money. So, and don't forget, error can be like to the right or to the left, which in natural sense, in modeling, what we measure is absolute error. And when something is absolute, you cannot say whether the error is going to like be in your favor or be against you, because absolute means like the negative value of that measurement is ignored. So that is why trading let us know the exact. And you can see that the trading, the S&P is giving us negative values, as you can see. HSI is giving negative values here for the return. But for our models, we got the positive value for the return, positive value for the Sharpe ratio. The volatility is a bit low or almost the same with others. And from the look of things in this table, it shows that our model actually give the best performance. So we also subject it to kind of a trading performance. So let's say the meaning of this trading means like if I invest $1, what will I get in the future? So this is 2021. So let's assume I invest $1 here. So in 2025, I will have made about $1.8. That's the interpretation of this. So likewise, the other data set being considered. And if you look at it from the look of things, you can see that this red, which happens to be our proposed model, perform better than other existing model like buying and holding LSTM, GRA, which shows that using that kind of proposed model, you get better accuracy and you also make better returns or higher returns. So, and our model is not just about the returns or the accuracy. Also in terms of runtime or computation analysis, our model is fast. We're in the age that people want to know, they want to work on real-time models. Real-time models means like something that as data is coming in, it's actually making prediction and forecast immediately. So in such kind of age, time is very, very of big paramount. So as a result, our model shows that this our model, our proposed model has the lowest time, as you can see in the table. The time it takes is like 4 seconds, 5 seconds. I don't know if you guys 4 seconds, 5 seconds, 5, 4 across all the data set considered. Whereas others are taking about 1 hour, as you can see, 2009, 16 seconds, 1228, and the likes. Also, in terms of memory usage, our model use the lowest of all the memories, very, very small, 2.2 MB, unlike others that are using like 1228 MBs and the likes, which shows that our model is not just only accurate, but also computationally effective. Okay, we compare our work with existing studies. As you can see, we compare with Tao et al. 2024, Gao 2020, and Zhou 2019. And these models they propose in their work are very sophisticated. Some of them are even attention-based. But despite that, our models still, supersede or outperform their models. Okay, managerial implications of our work is like it helps in decision making. It helps you to, a kind of cost-effective forecasting. Like it requires less money to implement, and also enhance your risk management. Then the future work, which is about LLM versus SLM. Yes, like this conference is all about generative AI than LLMs. But we like to say that SLM is more preferable when it comes to something like finance. Why? Because SLM, which is small language models, is more specific. For example, now, when you say LLM, it means large, like ChatGPT now is an LLM language model, and you can ask anything. Now, anything in finance, I don't need anything. I only need information that is particular to finance. So I don't need LLM because in processing LLM, it takes time the data sorting and the model complexity and also some other overhead and I mean like overhead computations and the likes takes a lot of time and computational resources. But SLM is going to be more specific. So like the only thing to okay.
You have less than 2 minutes.
All right, thank you. So we are of the opinion that SLM is more preferable for this kind of area than LLM. And this is the end of my presentation. Thank you.
Thank you very much for the comprehensive presentation. Thank you very much. I don't know if there is question and answer. If there is question, and Dr. Temtoko will answer it for us. And participants, kindly fill the feedback forms. It's in the chat. Question. Since we have no question for now, shall proceed to the next presenter. So that will be Ms. Sofeku Muyosore. You can share your screen and start presenting.
Good morning and good afternoon, everyone, irrespective of where you are. So I'll be sharing my screen now. Please kindly confirm it. And once again, I apologize for the disrupt to my network. Kindly confirm if you can see my screen, please.
We can't see your screen yet. We can see your screen, but you are not sharing the PowerPoint or slides yet.
What about now?
Not yet. So maybe still loading.
What about now?
Not yet. Not yet.
Share it to some other means, maybe WhatsApp, and then we can share on your behalf.
Okay.
Okay.
Sorry, has it come up?
No.
Okay, please. I would like to share via WhatsApp.
Okay.
Okay.
If while we are on that, maybe we can check if the next presenter is available now. We have Mr. Mr. Inyolua.
I think.
Okay, wait. Can you share now?
I think I've been able to fix it.
Okay,
Please
proceed.
confirm if you can see my screen.
Yes,
We
proceed.
can see proceed with it.
Okay, thank you so much once again, and I apologize for the back and forth. Okay, so good morning and good afternoon once again. My name is Moyosore Shofekun, and I'll be presenting on the topic, can generative AI preserve statistical properties? Study on distributional consistency in synthetic data. From the Department of Statistics from the Federal University of Agriculture, Abeokuta. And we'll be talking on this research topic because it is important to really note if generative adversarial network can actually preserve statistical property of the real data they are meant to mimic. And this is a very important question because synthetic data is becoming a known tool for privacy protection. But I mean, it's not useful if it actually distorts the true meaning of data. I'll be moving on to the background and motivation of this study. Why this study? In recent years, data privacy has become a top concern, okay, especially with stricter regulation like GDPR, that is the Generative Data Protection Regulations. Many organizations, they now generate synthetic data so that they can share or analyze data sets without exposing, sensitive information. And generative AI, and in particular now, generative adversarial network, GAN, they can produce data that looks real. So it's like GAN mimicking a real data set, trying to produce a data that looks real, but is not actually a real data set. So they can produce data that looks real, but we are not after visual realism, okay? In research and analytics, what matters most is whether the generated data behaves like the real thing statistically. If the statistical properties are not preserved, then analysis based on synthetic data could be wrong. The analysis based on synthetic data, they could produce wrong conclusion, which is dangerous in fields like medicine, finances, or policy making. So now we are not focusing on GAN because synthetic data, they can actually produce wrong GAN fields. What are the limitations when we apply them in practice? Moving on to our methodology. For our methodology, the first step is we started by creating a control data set where we knew the exact statistical properties, the normal, the binomial, and the skew distribution. This control was important because it allowed us measure precisely how close the synthetic data came to the real thing. So the second step of the methodology was to train GAN models on these data sets. And the third one was to generate synthetic data set. We generated synthetic data sets. And our last step was to compare the real and the synthetic data using the mean and variance comparison, the Kolmogorov-Smirnov test, the QQ plot, the highest order moment, the skewness, and the kurtosis. So the Kolmogorov-Smirnov test was used to assess the overall distribution match. We used the QQ plot for visual comparison of the quantiles, and the higher order moments like skewness and kurtosis was used to capture the deeper structural similarities or differences. So this multi-pronged approach ensured that we aren't relying on a single metric. So moving on to the observation and the results we got. So under high fidelity condition, there was large sample size, there was symmetric distribution, there was low noise level. And under Watts breakdown condition, under this condition of small sample size instability, high noise distorted tails, highly skewed data, poor reproduction of extremes. So our results show that GANs perform best when the data set is large enough for the model to learn, when it is symmetric in distribution, and low noise level there means under this condition, the statistical properties matched very closely. However, in small data sets, or when the data had a lot of noise, or when the distribution was heavily skewed, the model struggled. So we observed that the largest differences in the tails of the distribution, the rare events, which are often the most important domains. Moving on to slide 6, example. We did the QQ plot and the KS test. KS test is the Kolmogorov-Smirnov test. So here's under the normal data. So for the normally distributed data, the QQ plot lined up almost perfectly. and the Kolmogorov-Smirnov test gave a high p-value. So the p-value was greater than 0.05, meaning there was no significant difference. But under the skew data, we noticed that a deviation, especially at the upper tail, and the Kolmogorov-Smirnov test flagged this as a low p-value. And when we have a low p-value, it means there is a significant difference. So under the binomial data set, the match was good at the center, right? But the extreme categories were underrepresented. This visual evidence reinforces the fact that the statistical test and gives a clearer picture of where GAN succeeds and fail.
Ms. Muller,
I should have added
you have 2 minutes.
I have 2 minutes.
Yes.
I'll be rounding up soon. Okay, so for our conclusion and implication. So in conclusion, GAN can preserve statistical properties under certain conditions. Okay, performance depends on data symmetry, the size, and the noise. And the implications are carefully reprocess data before training, always validate synthetic data with statistical diagnostic, avoid relying solely on synthetic data in extreme scenarios. That in conclusion, GAN can indeed preserve statistical properties, but only under certain favorable conditions. They do well in they do well in clean, they do well in symmetric data sets, but they have limitation with noise, with skewness, and small sample size. So the takeaway now is when we are trying to use a generative before model training, we should validate synthetic data statistically, not just visually. And we should be conscious of high noise or extremely tall scenarios. So synthetic data is powerful, right? But without proper check, it can quietly distort your conclusion. And we plan to do our research more to elaborate and do so much research. And the next step for our research is involving testing new generative model to see if they actually overcome this limitation. Thank you so much. That will be the end of my presentation.
Thank you very much for the comprehensive presentation. Thanks. I don't know if there's any question and answer. We can have it if there is any question. Okay, please fill the Google Forms for the feedback for the presenters. Now, we are running out of time, so I'll proceed to the next presenter. Do we have Mr. Ibrahim Adebayo? Adiremi. Please, you can start if you are here. Mr. Ibrahim Adebayo Adiremi.
Yeah, thank you. I'm here.
Okay.
Can you hear me?
Yes, we do. We can hear you.
Please, sorry, I'm trying to share my screen now.
Okay.
Sorry, can I send it to one of the committee email? I think I might
Yes,
be issue
please
with sharing here.
proceed. You can find
Sorry, what?
you can find Mr. Motibe. His number is on the chat, so you can send to him.
Okay, let me do that now. Thank you. I was actually asking for someone to send me the email before because I think I might have issue with my sorry, I can't find the email.
While we are doing that, maybe we can proceed to the next presenter, Mr. DME IT. Mr. DME IT.
Sorry, please, I can't find the email you said you sent to.
Is a mobile number?
Mobile number. Oh, okay, okay, I'll find it.
Send to WhatsApp.
Okay.
Yeah.
Okay, okay. All right, I will do that right away.
Hello. Please, Mr. Adeyemi, IT said I should share his slide on his behalf. So he will be speaking and I will be sharing his slide.
Mr. DME, we can't hear you. Maybe you can try to increase the volume or you can maybe speak louder.
Let me check it. Are you seeing
Hello?
Yeah, we can see the slide.
Yeah, but we can't hear him.
The code me is having a network issue that I can share the slide while he speaks, but I don't know why he's not showing it again.
Mr. DME, are you with us?
Maybe another speaker.
Okay.
That number is not mine. I just helped the person to paste it. It belongs to one Mr. Mr. What now? I think Utibe. Yes.
Oh. Okay,
It-
yeah. Okay, I thought.
I will.
Mr.
Mr.
Ibrahim,
Utibe.
I think Mr. DME, Mr. DME, hello? Mr. DME, maybe you can unmute yourself and let's check the speaker if it's audible now. Hello? Mr. Ibrahim, maybe you can send to me. The last contact is
Okay.
mine.
Sorry.
Maybe you can.
Okay, 08166 is right?
Yes, you can do that.
Okay, let me please send it to your WhatsApp then.
Mr. DME, we can't hear you. I don't know if you can like unmute yourself and test the speaker again.
The causal explainable AI, which is helping us to interpret more of the machine learning output or artificial intelligence output that predicts water quality. But if you don't have this explanation, the common, the farmers, the common citizen that doesn't know much about the machine learning will not know the meaning of the output of the product of machine learning. So the explainable AI is trying to give everybody opportunity to understand what the product of machine learning is all about. Next slide, please. Next slide, please. Yes, how does this explainable AI works? It works after we have trained our data, we have collected data, we have processed them, we have trained them, we have tested them, we have deployed them, we have monitored them. The explainable AI will now be included to explain the product, the output of the AI models. And in that case, give everybody opportunity to understand what is being done. Next slide, please. Now, this is a taxonomy of explainable AI. Majorly, we have the model agnostic and the other one. And out of all the model agnostic, we have the local interpretable model agnostic, which is LIME, and we also have the sharply additive explanation, which is SHARP. These two explainable here has been used in most water quality explanation, which gives a very good result, especially the SHARP. SHARP has been used by various researchers across the globe, and it's giving us more, well, let me say, it gives more results than even the LIME, but the two of them are very good. Next slide, please. Now, if you look at this screen, you will see the application of the explainable here across the sector. And as a matter of fact, water quality monitoring has the most percentage, although it also is used in other sectors like the energy, the manufacturing, the finance, and the likes. But as a matter of fact, water quality monitoring is mostly because everybody drinks water. So if you drink water that is polluted or that is contaminated, that is very close to everyone, or let me say you get disease. So that's why people, the researchers are much concerned about how we can explain the machine model output to people. And when you use machine learning to do particular prediction, how do people understand what they have done? So we use explainable AI to do that. Next slide, please. Now, this is the research methodology we used. We actually use a Scopus database to generate data. And after everything, we got just 60 journals that are articles that are useful for this research. Next slide, please. Now, in this slide, this is one of the research findings that we had. This is the annual distribution of the publication of the explainable AI in water quality monitoring between 2011 and 2025. July 2025, as a matter of fact. We see that in 2024, we have the highest number of application of explainable AI on water quality monitoring, in which we have about 25 applications alone in 2024. This 2025 already, and you already have 20, meaning that before the 2025 ends, we have more than 2024, all things being equal. So this explainable AI is applied to water quality monitoring because of the importance of water to everybody. Next slide, please. Also, in terms of the country that are really dealing with this AI, explainable AI, China take the lead, followed by the India and the USA. And as you can see on the screen, we have this country leading the application of explainable AI in water quality monitoring. Next slide, please. Next slide, please. Yeah, so in terms of the areas whereby we apply this, we have the environmental science that led the portion. As you can see, we have other engineering, we have the health sector, the agriculture and stuff like that. They are also applying this explainable AI in their domain to explain the machine learning prediction. Next slide, please. So in terms of water quality monitoring, we have different aspects of water quality monitoring, which is we have the water quality, we have decision in water distribution system. We also have the forecasting of the future. So the out of everything, the water quality parameters take the lead in this aspect, in which we use it mostly to determine the temperature, the pressure, and some other stuff that are very paramount in water quality we drink. Please, let's continue to the next slide. And these are some of the case studies that they have used the water quality, the explainable AI to determine the prediction of what machine learning model used in particular water quality assessment. We have the one from the Sonata, and this one was done on groundwater. We also have the non-lector in 2024, which was done on surface water. I also have the LEW in 2024 again, which was on wastewater treatment. So all these areas, we have a lot of them. I'm just selected these three for our case study. Next slide, please.
Mr. Ibrahim, you have 2 minutes.
Okay, thank you. And these are the areas whereby this explainable AI can be useful to our stakeholder, to the scientists, help us to reproduce our hypothesis, our machine learning models, help us to explain what we have done. Is it very correct? How can people understand what we have done? To the policymakers, we can actually trace what we have done. Our machine learning models, are they useful for everybody? People that make policy about things. Also for the operators, like the farmers, the water personnel in the water works, how can they improve their efficiency? So to explain the water quality to the populace that are taking the water and to the community, everybody will be able to understand what is happening. Many people are now getting involved in machine learning, of course, but they don't understand what is being the output. So explain where we tell people how these things are working or what is the implication of what they are getting from the machine learning models. Next slide, please. Of course, we have some of the challenges we face. Of course, everything that we do, there's always challenges, especially all this machine learning evolution. We have the technical issues, we have the methodological issues, and we have the data challenges and social technical challenges, which can be solved in the future. Next slide, please. These are the future direction. Explainable AI is good, but we also need to incorporate with other aspects of learning and machine learning models. Like, for example, we can also have also explainable AI, we have the benchmarking and the evaluation. We have the robustness. I mean, these are the areas where we can deal with in the future. Also, we have the remote sensing, the GIS, geographical information system. Also, we have the policy compliance and equity. These are the areas whereby we can work on in the future. Next slide, please. Now, my conclusion, explainable is vital for safe, equitable water management, but we need to collaborate with other stakeholders to ensure that its output also gives the actual expectation that people will learn from what machine learning cannot produce in the real sense. Because we want to explain what machine learning output is, we need to explain it in such a way that people also understand. So these are the reasons why we need to incorporate explainable AI in our machine learning models. Next slide, please. Yeah, take away. Explainable AI turns water quality monitoring from black box into a clear window. So when you build trust in the result of machine learning models, it gives us a better decision, and it ensures our most vital resources, which is water, is spread from transparency, and it's spread with transparency and accountability, so that everybody will believe in what they are drinking, and they will not be thinking that they are actually being poisoned by what they are drinking. All right, these are my references, and thank you for listening.
Thank you very much for the wonderful presentation. Questions can come in now. Mr. Destiny, maybe you can send to me on WhatsApp, and then I will share my screen on your behalf. Maybe you can do that.
Okay, thank you for your presentation. I have a quick question. From
Okay,
the
sir.
slide, one of the slides from
Okay.
to the presenter, from 2013 to 2019, there was no indication that there is a publication, or during that period, what happened? Prior
Yeah.
to 2018, we had, and then after 2019, they still had. So
Yeah,
what happened?
thank you very much.
Or what kind
During this period, this just when if you look at the slide very well, you realize that I mentioned that the evolution of machine learning gives rise to explainable AI. So during this period, when the machine learning is growing, I talk about the prior 2015 and after 2015. Prior 2015, we have all decision trees and stuff like that. Then there was no explainable AI being actually used in those periods very well. But those periods, there was nothing, meaning that the researchers don't put much interest in the area of research. I mean, they don't apply explainable AI to water quality monitoring. That doesn't mean work are not going on machine learning, but they are not applying explainable AI on water quality monitoring. That's why from 2013 to 2019, there was no paper at all on explainable AI for water quality monitoring. Thank you.
All right, thank you.
Yes, sir.
Mr. Destiny. Mr. Destiny. Please, you can share your you can send your slide to me, then I'll share on your behalf while you present from your side. Mr. Bakari, are you here? Abdulatif Bakari, is he here? Mr. Isaac. Mr. Isaac, maybe you can have it
Yeah,
first.
yeah.
Yeah,
All right,
it seems the
sir.
speaker is
All right.
good now. You can start.
Okay. Please, I would have sent the slide that I would love it if you can start present. Dr. Kennedy slide. I'm so sorry for the delay. Okay. All right. Thank you so much. And I'm so sorry for the delay once again. I'm Adeyemi Isaac Tokwe by name, and I'll be presenting an hybrid approach that can predict eye strain risk from smartphone exposure, which is titled Artificial Intelligence and Mathematical Modeling for Predicting Eye Strain Risk from Smartphone Exposure. Next slide, please. Smartphone has been, a lot of people do have phones now due to the advance of technology, and a lot of people do spend quality time on phone, not knowing the effects, the side effects that cause the eye strain and is damage the health, the general health. Please, next slide. And that is why this study adopts a hybrid approach by integrating artificial intelligence and mathematical modeling, which is delayed differential equations with the artificial intelligence to predict eye strain risk from smartphone exposure. Statement of the floor, please, next slide. The exponential growth of smartphone has led to a surge in cases of digital eye strain, yes, and recent studies, according to Kahal et al., it shows that nearly 69% of users experiences symptoms like headache, blurred vision, eye discomfort due to the fact of spending more time on their phone. And a lot of people don't know that spending more times on phone leads to headache, blurred vision, and eye discomfort. And they don't even know when to take care of their eye strain and when to take care of their eye and when to make sure that they have to spend less quality time on their phones. And based on existing research, it shows that eye strain, normally they're not eye strain purely as medical or ergonomic issue with limited integration of predictive modeling and mathematical simulation. Yes, and there's this thing that a lot of people have worked on artificial intelligence for predicting eye strain, but few research have worked on combining mathematical modeling and the artificial intelligence to predict the eye strain risk from smartphone exposure. And that is why this framework came up so that it can combine artificial intelligence and mathematical modeling to understand the progression of symptoms over time, enabling early intervention. And the objective is very clear: to develop hybrid predictive model that integrates supervised machine learning with delay differential equations to estimate individual eye strain risk. Okay, so that everybody will be able to know when to spend less time on their phone and when to proceed. And the methodologies, please, can you move to the next slide? The methodology. All right. This research integrates, as I've said earlier, that it is a combination of AI and delayed differential equations. And though it was not we use 70% of the data sets to train and 30% of the data sets for testing. And it was a simulated data set. 1,000 details were used, and it was used. Everything was done in Visual Studio Code using Python, and the breakdown of the workflow was the data simulation, the model development, model validation, and system implementations. Those are the step-by-step process that we use for the methodology. And as I've said earlier, that we make use of simulated 1,000 data sets to make the prediction. And based on the outcome that shows, please the next slide, based on the outcome that shows, it shows that the model was evaluated using, please next slide. Next slide, please. Yes, based on the result, the model was evaluated using precision because evaluation matters and when to know when to train to test our, maybe we are going to split our model into training, testing, and evaluation, but this particular one doesn't need all that. It just needs to test the precision, the recall, the F1 score, and the accuracy. And it was categorized into 3 risk classes. We have the high risk, we have the low risk, and we have the moderate risk. In the high risk, it shows that in this category, the precision is 1.0, and the recall is 0.82, and the F1 score is 0.90. While the low risk school, in the category section, we have the precisions to be 0.91, we have the recall to be 0.93, and the F1 score to be 0.92. And in the moderate scores, it shows in this category that the precision just shows the evaluations of the model to check whether it is accurate or not and to check where to work on. And in the results, it shows that the overall accuracy is 96.03, and we have the macro average F1 score to be 0.90. Same thing with the weighted ones to be 0.96, which shows that the hybrid model performs very well across all risk categories. And the main reason why we break this thing down into 3 risk categories is just to be very sure of our precision and our accuracy, and when to know, so that we can know how to improve our model, our hybrid model. So please, can you move to the next slide? All right, please, can you move to the next slide? All right, so in conclusion, the hybrid model effectively classifies high strain risk level using screen behavior features, because we used a lot of screen behavior features. We use screen time, the numbers of time users spend on their phone. We use the brightness, we use the blink rates, and we use the symptom severities to work on our model. So in the conclusion, we can say that the hybrid model effectively classify high strain risk levels using screen behavior features. The high accuracy, balanced performance across all the classes. The classes were the high risk, the low risk, and the moderate risk, and which shows how effectively and how reliability of our hybrid approach. And in conclusion, again, we can also say that this reinforces the potential of AI-powered tools in personal health monitoring. So each individual can monitor their health by making use of, when we deploy this model, people can make use of it to personalize for their own personal health monitoring, to know when to stop from spending time on their phone and to know when to continue. And it also helps in enabling early invention through predictive insight. Thank you so much for giving me this opportunity, and I'm grateful for that.
Thank you so much for the nice presentation. Do I have a question for him? Any question? Okay, if there is none, do we have Mr. Abdulatif? What about Mr. Abdul Wasu? Sorry for the pronunciation. Do you have him here? Any other presenter that is here to present?
Mr. Destiny is here to present. Destiny Orobusa.
Okay.
time for this. That's why I said the study was limited by funding. And even without funding, we could have carried out in vivo analysis in the lab using no.
Can you share your screen? Mr. Destiny, can you share your screen?
Good morning, good afternoon, good evening, wherever you're listening to me from. I am Mr. Destiny Omogete Orobusa from Ambizali University, Ekuma, a graduate of Ambizali University, Ekuma precisely. Sorry, I can't. I'm unable to share my screen right now, please. I don't know if you can bear with me, or if I could send it to
You can send it on
anyone here so
WhatsApp and we can appreciate.
Okay, via WhatsApp.
Yes, send it on WhatsApp. Check the chat. You
Hello,
can
come
find
again, sir.
Yeah, send it on WhatsApp.
Okay, send to WhatsApp. Okay, let me just meet my. Let me just. Okay, hold on. Let me quickly send it, sir. I want to send this. Sorry, please. I'm sorry. Okay. I'm sorry for the delay. I'm back right now. Hello, can you hear me?
Yeah, we can hear you.
Okay, I've sent
I'm
it
trying to
to
download now.
one.
Yeah, I'm trying to download.
Okay, thank you very much.
Okay, thank you so much. So a very quick one for Sunday. My network. I have my name. Okay, Dr. Chilazo. Sorry, the question I asked was what's the limit of what you use for your qualitative synthesis of terms?
Okay, I'm still waiting. I'm sorry for the delay, please.
Do you have the screen now, right? You have your slides. You can start, please. Mr. Destiny, please start. You lost Mr. Destiny. Have the floor. Please start.
I'm waiting for the slide.
The slide is up.
So I'm yet to see my slide on this.
Just use your version of the slides. I think others can see the slide. I'm sharing it currently. Present with your version. We try to cope with it. Mr. Destiny, are you here?
Okay, thank you so much. I'm back now. Okay, my name is Omogiate Robusa Destiny, graduate of Ambuzali University, Ekboma. I'm sorry, please. Can you all see me?
Yes, we can. Just proceed.
Okay, my
Proceed with your
topic is
presentation.
before I dive into my topic.
Okay.
Okay. Okay, I'm pleased to present my topic, design, automation, and development of a remote control lawnmower, or evaluation precisely. Let me begin by highlighting the key problems in this project. Traditional lawnmower, both manual or gas-powered lawnmower, comes with a high range of challenges. They are labor-intensive, noisy, environmental unfriendly due to carbon emission, and require constant supervision and regular maintenance. This issue limits their flexibility, efficiency while carrying out or while mowing on the field, particularly on larger or remote communities. To tackle this limitation, I and my team designed a remote control lawnmower that integrates Internet of Things, which is the IoT technology. This approach allows users to control the mower using your smartphones as a means of remote with a Wi-Fi to hotspot connection, not more than 20 meters. And this improves accessibility and easy to use. I'll be highlighting the key components in coupling this robotic lawnmower. Well, we have the 6.5 horsepower engine for the robust cutting, the 6.5 horsepower engine or the grounded engine, or we call it in engineering, we call it internal combustion engine for robust cutting power. We have the DC motor for direct control system for movement and ease operation and to ease operation, sorry. And we have the stainless steel blade for effective cutting, and also the alternator which serve as charging the battery and to ensure extended operation time, and a user-friendly dashboard interface featuring directional controls blade and activation, and also battery status indicator. Materials used for this project, materials used are the mild steel and the stainless steel. And you may ask, why mild steel or why stainless steel? Why I use mild steel? Why me and my team we use mild steel in coupling this machine is because one is because of its durability, strength, and cost effectiveness. And stainless steel because of the shining. Sorry, hold on. Hello, can you hear me?
Yes, we can. You can. We can. Please continue.
Hello, can you hear me?
We can hear you. Please
I'm
continue.
sorry for the glitch. I'm sorry. Okay. Why, to tackle this limitation, we designed a robotic lawnmower that is with an IoT, Internet of Things technology that can be controlled using your smartphone, which serves as your remote, not more than 20 meters from the distance while mowing on the field. And while carrying out a performance test and evaluation, I conducted a field test across a 7 plots covered on a carpet grass on the average capacity, confirming the reliability and scalability of the system. This research put into overcome limitation of the previous work done by other researchers, such as hello, can you hear me? Hello, can you hear me?
Yes, we can hear you. We can hear you. Proceed.
Okay. Further research on robotic lawnmower. Okay, let me just go in conclusion. Okay. Sorry, let me just have to wind back a little, please. Okay. Hello, can you hear me?
Yes, we can hear you.
Please, I want who is controlling the slide, please go to the front page. The first one, please. Just want to quickly explain it again for proper understanding, please. Okay. No, the second one. Okay. Sorry, the methodology, please. The methodology. Okay. In carrying out this research, material selection was put into consideration while selecting several components in use in joining these components together, such as the mild steel and the stainless steel. Why, you may ask, why mild steel? Because of the durability and the strength of which the machine can carry, and to ease movement as well. And why stainless steel? Stainless steel is because for the cutting ability and to avoid corrosion. Sorry, that's why I use stainless steel in as one of the components in this research. Sorry, the next page, please. The next page, please. Okay, the 6.5 horsepower engine was used, and it has been Everything in this machine are locally sourced material. I got it from the market here in Nigeria. I took it to the fabrication shop where I have the 6.5 horsepower engine, this DC motor, the alternator, the car battery. They are all locally sourced material, and the tire and the wheel, the tire width to ease movement, they are all locally sourced material. Please, the next page, I want to quickly explain the orthographical drawing over there. Hello, please, the next page. No, the next one, please. The orthographical drawing there. Okay, thank you very much. Okay, here on the screen we have the automatic lawnmower parts. Okay, yes,
Hello, Mr.
I'm okay with
Destiny.
this. This is the isometric drawing. The three, sorry,
Sorry,
please, next, the
Destiny,
previous
you
one,
have-
please. The previous one. The orthographical drawing, please. The 3D orthographical drawing. Sorry, the 3D orthographical drawing, please. I don't mind. Okay, my time is almost up. Sorry. Okay. Here on the screen is the 3D orthographical drawing. You're taking it away, please, sir. No, the 3D orthographical drawing, please. Okay. Everything you see here, they are locally sourced material. We have the microcontroller, which is an AI built-in microcontroller with the help of your phone serve as a remote to ease movements not more than 20 meters.
Hello, Mr. Destiny. I think we've lost connection. Okay, I think we will stop for the. Do you have Bakare, Mr. Bakare? Mr. Bakare,
Is Bakare the last presenter?
yes.
Okay.
Others too, they are not around.
Okay. If he or she is not here, I think we can just move to the Q&A. Maybe 2 questions, and then we can conclude and then move to the main room.
Okay,
Thank you.
thank you. Do you have any other question for any of the presenters? Any questions for our presenters?
If there are no questions, we can